precision. Precision literally means how correct or how exact we are with our prediction or whatever claim that we are making. Similarly here, so the precision is the how of all the instances the model predicted as positive, how many were actually positive. So if we take that shirt case, okay, actual shirt, if we consider that as a positive, so of all the shirts that the model predicted that it is a shirt, how many were actually shirt? This ratio, this is the precision. Okay, this part of all the predictions made by the model that these are shirts, which were actually shirt. These were actually shirts, true positives. These are false positives. These are not shirts. So this is your false positive rate. So what is precision? This is your, what will be a ratio? This will be your true positive by true positive plus false positive. I hope this is clear. It measures the quality of your predictions. Out of all the predictions you made for positive class, how many were actually positive? Of all the predictions you made about the shirt, how many were actually shirt? Okay, these were falsely made, declared as shirts. Similarly, there is another metric called recall. Okay, and the recall is, what do we mean by recall? So of all the actual shirts, so actually these were all shirts. Of all the actual shirts, how many were you able to identify correctly as shirts? Of all the positive instances, okay, how many was the model actually able to identify as positive label? Or of all the shirts images that I had, how many, okay, these are the actual shirts. Of all the shirts, how many was the model able to actually identify as shirt? So this is in this direction. Okay, so this will be your, of all the shirts, how many was the model able to correctly identify as shirt? So this will be true positive plus false negative. Some shirts were not identified as shirts, so I'll include these now. So this recall says that how much, whatever it has seen, how much it was clearly able to recall. So it will be true positive plus false negative. So I will give you a just quick hack. If you put actual here and predicted here, and the positive class first and the negative class second, so everything on this line, okay, this by this will give you your precision, and this by on this line, this will give you a recall. So here you will get precision, here you will get recall. If predicted is here and actual is here. Just a shortcut to remember, but you can just plot it, and if the concepts are clear, you will figure it out. I hope recall is clear. This is your recall. So if precision and recall is clear, then we will move to the next topic, that is your F1 score. F1 score is nothing but it's harmonic mean. So you have arithmetic mean, right? So similarly, we have harmonic mean of precision and recall. And there's a reason, okay, there's a reason why we take harmonic mean. I'll demonstrate that with an example. So this is a harmonic mean. So what will be the formula? So F1 score will be, so this is one of another scores to measure the metrics. It is just using precision and recall. So there's nothing new, and it's just a harmonic mean of the precision and recall. The formula will be 2 into precision into recall by precision plus recall. Okay, precision plus recall. So harmonic mean analyzes extreme values. Okay, whenever we have one value as extreme in this, in this, any of them is very extreme. Okay, and this will range from 0 to 1, right? So because the max can be 100%, so this will be 1, and the min can be 0. There can be, it doesn't identify anything as positive. So minimum will be 0, max will be 100. So these values will range between 0 to 1. Similarly here also, because that's the harmonic mean of that. So for example, if I have two values, if I'm getting precision and recall, let me show you an example. For example, I have precision score, I have recall, I have got this from the model's values what it has got, and I have got F1 score. And say for example, I have arithmetic mean or average. I'll write average, that is a common term that we know already. Okay, so say for example, if my precision is 0.5 my recall is 0.5. So what will be my F1 score? 2 into 0.5 into 0.5 by 0.5 plus 0.5. This denominator will be 1 and this will be 0.5, because 2 into 0.5 is 1 and remaining will be 0.5. So this will be, sorry, this will be equal to 0.5. Similarly, I will just write the other values directly. So this is how you calculate. So the average will of 0.5 and 0.5 will be 0.5. So next we'll say, for example, if my precision is 0.7 and recall is 0.3, then similarly if you calculate, you will get a precision of 0.42. But what will be the average here? Arithmetic mean. Now you see the precision has improved but the recall has gone down, but still my average will be 0.5 only. But you see now it has become less because the recall has gone down, so it should show that it is less. This is not, means this is worse than the previous score. Similarly, if the values become more extreme on one side, say for example if I have 0.9 as precision and 0.1 as recall, so what will be my average still? It will be still in the middle. But the recall score, if you see, this will go down to 0.18. So this is the beauty of F1 score, that it penalizes extreme values, and because of that, that impact will be visible in the F1 score if any of the values is very low, and because of that the F1 score will go down, but the arithmetic mean won't show that. I hope this is clear. So this is your F1 score, simple. Now I'll give you a note when precision will be important. So there are two metrics. So out of this F1 you have to balance in the F1 score, right? Which one should I go for? If one goes up, other will go down, right? So there will be always some trade-off between them. And finally, so when should we focus for precision? So when should we have precision focus? So when should we have precision focus? So whenever the cost of making false positives is very high. So whenever we have the cost of making false positives is very high, because that's what it captures, because the false positive is very high, because this is same, true positive is same, but the cost of making false positive is very high. Okay, then this is the error we are making, right? So when the cost of making false positive is very high, in that case precision, then precision should be focused. False positives are very important. For example, say for example, I have an algorithm or some way, a mechanism to identify a potential terrorist. Okay, for example, when we want to identify a potential terrorist, so if we say falsely, if there's a false positive, means there is some innocent person whom we falsely identify as a terrorist, that will be very detrimental to that person's life and quality of life. Some person can be put into jail for no reason. Okay, so when we falsely identify a person as a terrorist, so these false positives are very dangerous, and that's when this precision focus becomes important. Similarly, the other way around, when should we focus on recall? Because this F1 score is a harmonic mean. So when the false negative, the cost of making false negative is very high, the impact of having false negative is very high. So what is such a case? Say for example, if we are having a medical test for a very serious medical condition, that time, if a person has that disease and we miss to identify that disease, falsely we say that no, this person doesn't have that disease, in that case false negative can be very costly and it can cost some person a life. So that time we should be very focused on the recall. So I'll give you the example. For example, medical diagnosis of a serious disease, medical test or a diagnosis of a serious disease. We should not falsely miss to diagnose any test. So that time the cost of false negative, and we should focus on recall that time. Okay, so I hope this is clear. So let's quickly put some numbers and understand this. So let's put a problem. and understand this. So I'll just put, you will have the numbers, and now you have, if you've got the fundamentals now, then it should be very easy. Say for example, I have access card in the company. Okay, so I have access card for authorizing someone to let in, or unauthorized if somebody doesn't have an ID card, or any website also, right? Access we have. So somebody who has a valid identity will be authorized to get in to the office, and somebody with no ID will be not allowed into the office or in the system or on the online if you try to log in. So this is what my access system is doing. So let's now, so we have a data for n is equal to 1000 access attempts, maybe your office or some website. Okay, so now let's draw the confusion matrix for this. So this side I'll put my actual data, here I'll put my predicted data, and then let's draw the matrix. Something like this. Okay, whatever, the last line may not be, that is okay. This is there. So actual, this is actual is there. Okay, so someone who is actual, I'll leave this, I'll write here actual authorized to enter, and then you predict, or the system predicts that this person is authorized. Okay, and then there is some actual unauthorized person. This person should not be let in the system, and now the system will have some bugs. If it's a software system, that may have some bugs. Okay, and then this predicted unauthorized access. Okay, so this is the data we have. So the data what we have is, here we have 90, 10, 1, and this is 899. Okay, so whatever comes in my diagonal elements, these are good, because this was actual, predicted actual, this was authorized, predicted authorized, this was unauthorized, predicted unauthorized, all good, no problem. But the confusion is here. Okay, that's why it's called confusion matrix. So this is your true positive, this is your true negative, no problem with this. The problem is with the your false positive and the false negative. So somebody was actually authorized and you predicted authorized, no problem. Somebody was actually unauthorized, you predicted unauthorized, no problem. The access system is working fine. But if somebody was actually unauthorized and your system predicted it to be authorized, maybe that person is a hacker or with some fake ID, somehow that person got into the system. So, but only one person was allowed. So still the system is performing well. Okay, so this is good. And now, so you let one hacker in. So we'll calculate, because the system won't be 100% proof, right? So we'll calculate all the values, precision, recall, F1 score for this. And similarly, somebody was actually authorized, but the system predicted it as unauthorized. Maybe the access card is broken, or the magnetic strip is not functioning well, or there is system, some problem, some fault happened. So actually, these 10 people faced some hassle for getting from getting authorized, and the system flagged them as unauthorized, and they were not let into the system. So this is the whole problem. And now let's quickly do all the calculations. We have all the numbers. So what will be my precision? My precision is true positive on this line. True positive by true positive plus false positive. This is equal to 90 by 90 plus 1. This will be very high. This is equal to 0.989, approximately 98.9% precision. Very good. It is, the system is very exact. What will be my recall? Recall is on this line. So this is your true positive by true positive plus false negative. So this is your 90 by 90 plus 10. So this is your 0.9, or approximately 90%. So even your recall is fine. Okay, only 10%. So 90 and 99, almost 99%. So what is my F1 score? So this is 2 into precision into recall by, I'll shortly write P plus R. Okay, so it's a 2 into 0.989 into 0.9 by 0.989 plus 0.9. So this will come out to be approximately 0.942. So this is a very good F1 score, because yes, my already my precision and recall are good. So this is your F1 score. So this is how you calculate. So I hope with numbers now it should make more sense and should be very clear.